In this video, I'm going to show you how to calculate the volume of cylinders. But before we actually get to that, I'm going to have one piece of vocab today. So as you see, it's the number of cubic units needed to fill the space occupied by a solid. Well, that is nothing more than volume. So how many little cubes can we fit inside? So what I did is I gave you a larger cube here, and I'm wondering, well, how many smaller, technically 1 by 1 by 1 cubes would fit in that? So what I have here is you can see that this could be pulled apart, and we could count every single one of these cubes that are involved in that bigger cube. And if you kept going, you'd find out this one actually had 27 of them, and there's a lot of them in there. I'm not going to pull them all apart, but that's what volume is. It's how many of these little cubes, unit cubes they're called, can be fit inside of that bigger shape. Now, when I say unit cubes, that could be 1 inch by 1 inch by 1 inch, or 1 centimeter by 1 centimeter by 1 centimeter, whatever that label is. Now, since we're talking about cylinders, we can't really fit these things perfectly in here. They just don't fit. But what happens is you can take those and cut them, make them fit into all the little voids, and we can figure out the volume of a cylinder. But we're not going to cut them, so there's a formula that we're going to use to help us calculate the volume of a cylinder. Now that formula looks like that. This big B that you see there, the capital B, that's the area of the base. Now keep in mind that our bases are circles. And we already know how to calculate the area of a circle, so I don't really like to think of it as that formula. I'll go back to this one. The B is right here, because the B, remember, is the area of the base. Well, the area of a circle is pi r squared. And then we have our little formula. If we have our formula, we can calculate the area of any cylinder. Height, the height is the distance in between those two bases. So how far is it from, call it the top height and the bottom height, or if we're looking at this one over here on the left, how far is it from the left base to the right base? So to help us go through this, I have a couple of examples. My first cylinder here, we have notice a radius of 9. I guess they're all connected. So my radius here is 9 yards, and then the 5 yards here, this is our height. So if I want to calculate the volume, I'm just going to use that little formula that was on the previous slide. Volume equals, if you want to think of it as the area of the base times the height, that's fine. But I'm going to go back to the area of the base is pi r squared, and then we have our height right there. So now it's just a matter of plugging numbers into our formula. I'm going to leave this pi as the pi symbol. Sometimes I know we'll approximate that with 3.14, but I'm going to leave it as pi right now so that I get what's referred to as the exact answer. Radius in our cylinder is 9, and we have to square it, and then we have to multiply it by the height, and the height in this cylinder is 5. And now it's a matter of calculating this. Some of you will jump right to your calculator and type it in like that if you want the approximate, but I'm again going to continue and look for the exact. So I'm going to take the 9, I'm going to square it. That puts us at 81. Still have the 5. And then we still have our pi. Now if I multiply 81 and 5 together, we get 405, and then times pi. This is the exact volume of our cylinder. Now, the label is cubic yards, because remember, this is telling us that if there's 405 pi, 1 yard by 1 yard by 1 yard cubes that fit inside of that cylinder. Now, those are pretty big yards, or cubic yards, but that's a pretty big cylinder there. Now, if we wanted the approximate value, now we're going to go to our calculator and figure out what this is. Clear those out. So I have 405, and I have to multiply that by pi. So I'll push times pi and enter, and I have it. Now this calculator, we don't have to put the times sign in there. It will still be able to calculate our final answer, because it knows that when the number and a pi are next to each other, it's multiplication. So when I come back here and I want the approximate value, I'm gonna round to the nearest hundredth. I know my problem isn't specific on that. Sometimes it will be. So I'll look here and go, 4 is in the hundredths place. 5 is after it, that tells me I have to bump that 5 or the 4 up to a 5. So when it's all said and done, my approximate volume is 1,272.35 yards cubed. So again, this is our exact volume, and this is our approximate volume. One more, just took the cylinder in it. It's just rotated a little bit, tilted, but it's still a cylinder. Okay. And again, our volume is going to be equal to, and I'm going to use pi r squared. There's the area of the base, and then times the height. So I'll plug numbers in. Pi, I'm going to leave that there. Radius, well, notice the radius this time is 5. I'll put 5 in for r, square it. I've got to multiply it by the height. Well, this time the height's here. And again, remember that height is the distance in between the two circular bases of a cylinder. And now we just go through and we calculate all this. Well, 5 squared is 25. We still have our pi, and we still have that height of 15. And then 25 times 15, that's going to put us at 375. Let me write that down. So we're going to get 375 times pi. And in this case, it would be cubic inches. That's our exact value. Now I want to figure out what's the approximate volume of this using my calculator. So I go back to the calculator. I type in 375 pi. We get our answer of 1,178.097, so on. And again, if I round this now to the nearest hundredth, that's going to put us at, well, that 9 is going to have to bump up, which means the 0 to the left of it is going to bump up to a 1, and the 100th spot's actually a 0. I'll come back here. Final volume, approximately 1,178.10 inches cubed. And I like to make sure that I put my 0 in there to let whoever's going to look at that know that I rounded to the nearest hundredth. And that's going to conclude this lesson on calculating volume of cylinders.